Hello everyone. Today I'm back again with one more video for the basics on embedded systems. Have you ever wondered how the headlights of the vehicle are controlled based on the night vision or a daylight vision mode, or how a specific an LED or a light can be blinked on a specific time intervals? Today we'll be talking about those peripherals of the embedded systems which will help the user to do that or achieve that. Hello embedded learners. I'm Geeta. I work as a technical director at GSAS Microsystems. So in this video, we will be covering on timers and PWM and what are its use cases, when to use what based on the requirement. And basically, whenever you are reading about the microcontrollers, or you might have come across this timers or PWMs anywhere in the data sheets or in the libraries or in developing some sample projects. So today just let's demystify it. What are these peripherals? What does timer and PWM do? On the theoretical level, not on the coding level, just to understand the general concepts, and based on that you can further work on developing a project based on these peripherals. So let's get into it. So first let's talk about timers. So timers is basically, it increments or decrements. It counts the number of clock cycles, either incremental way or decremental way. So this timer is driven by MCU clock source. So if you take an example of a Cortex-M microcontroller which operates at 72 MHz, so you can configure this timer to count for every clock cycle. So 1, 2, 6, 8, basically we call it as a Prescaler. So if you consider a 16-bit timer, so it can count up to say 0 to 65536. So after it counts to 65536, it overflows, it generates an interrupt and then again starts executing from the value 0. So this timer can be used like an auto increment or decrement, and with the help of this value with which the timer starts execution, you can change this value. Usually call it as auto reload value. So this value will decide at what interval you want the timer to generate the interrupts. So why this interrupt is required? Probably when you want to generate some events which has to be generated periodically, or you want to use the timer for some delay related application, or you want to generate a specific delay of few milliseconds or microseconds in your application. So timer would be the best option. Another advantage or functionality of the timer is you can use timer to generate the PWM. So now let's see what is PWM. PWM stands for pulse width modulation. So what does this PWM do? Basically it simulates the analog behavior using the digital signals. So a digital is just 1 or zeros. So suppose you are turning a switch on or off. The digital on means when you're turning the switch is on, it is digital on. When you're turning the switch is off, it is digital off. But what if you move the switch for a continuous time, fast speed? This is called as frequency. So frequency is in a defined time period, how many times the signal repeats by itself. That is called frequency. Okay. So what is a clock cycle? Clock cycle is a addition of the signal on time and the signal off time. So in this clock cycle, a signal can be sometimes be on, rest of the time it can be in the off position. Okay. So now in PWM we see something called as duty cycle. So what is this duty cycle? You might be seeing in this slide. Okay. So this duty cycle is basically how long the specific signal is on. What is the percentage of the time the signal is on? That is actually a duty cycle. Basically the formula is on time divided by the total time period or the total signal cycle, that is on and off, sum of those. So what this is used for? Basically it is used for LED dimming. The start of the video I did tell you, for headlights of this automotive vehicles, or you can control the speed of the motor without using any analog voltage. You don't require analog signal at all, because using PWM you are simulating the analog behavior. Right. So now let's see how a timer can be configured using a PWM. That is the most interesting topic, because Now, modern microcontrollers have PWM as a separate peripheral itself, but not all the MCUs has this PWM. In such cases, you can still configure timer to generate a PWM signal. So now let's see what is required to configure the timer to generate a PWM signal. You basically require a timer peripheral, which will act as a counter, and a compare register. So compare register is holding some threshold value. I'll come to that. What is the functionality, advantage, and where it gains the necessity in the PWM. So as I said in the timers also, the clock source for that particular timer can be MCU, or it can be Prescaler, or the counter value, like I gave auto reload value, like that. The counter can also have some value. So that will be the clock source for this timer, which is used for the PWM. Now let's see, I have loaded some value, say 99 or 100. So timer will start counting from 0 and it goes to 100. Suppose in my compare register, if I have kept the value 100, then as soon as the timer counter value reaches the 100, it will be on, and once it reaches the 100, the signal will fall down. So basically this compare register will tell how long the signal is in on position and when it will come to off position. So that is called as duty cycle. So basically it concentrates on how long the particular signal is in on position. If the signal is not on position, it will be in the off position. So duty cycle is 0%, means the signal is always off, means the PWM signal is always off, or the timer, the signal is off. If the duty cycle is 50%, it is 50% on, 50% off. If it is duty cycle is 100%, then the signal is always in the on condition. So the basic beauty of this PWM is using this clock period. The period of these timers will be using that as a frequency, and by keeping this frequency constant, you can use this duty cycle and generate the required PWM signal which is required for your application. Right. So now if you take an example like an MCU, you have selected say some Cortex-M, because I've been doing these videos for embedded basics using Cortex-M. So let's take an 72 MHz or 100 MHz MCU, and it has a prescaler of 8. So probably you will have operating speed as 125 kilohertz. And then we have this counter value, say 125, like that. So basically you can set that, and you can see how keeping the frequency constant by just varying the duty cycle, you can get the required PWM. This dimming, the speed of dimming, everything can be controlled through this duty cycle. So duty cycle plays a major role here. So that is the main thing to focus on. So now we have seen this, where this PWM is being used and how the timer can be used for generating the PWM. So I would like to give kind of motivation to the learners, embedded learners. So you can start first working on a timer. You can try to control the blinking of the LEDs or a GPIO pin with some delay. So configure timer for that. And then next step is find the clock source for the timer from the datasheet of that specific MCU. And then you can set a specific clock period and then comfortably set the frequency, say for 1 kilohertz, and then try to see how the PWM signal plays or displays based on the value that you program into the compare register. So this particular video, I'm sure the learners would have got some information on theoretical concepts of how the timer and PWM basics work. So as I highlighted, this is just a theoretical concept. So I would encourage embedded learners to first work on this, understand the concept, and then start building a project on a simple microcontrollers. Could be an 8051 or it could be an MCU. I'm sure the learners would have got some basic view on how this timers and basics, timer and PWM basics work in general, theoretically. And I would encourage the beginners to start working on this. I'll see you soon in the next video. Bye.